Okay, so nothing new today. It's just to get this back in your brains and thinking about it. I want you to grab your calculator out, because you're going to need that. Okay. Okay, so you've kind of seen something like this a different day, but one of the standards that the state says that you guys need to know is calculate with positive and negative rational numbers with whole number exponents. We need to be able to compute simple interest, all of those kind of things, which all deals with percents. So we're going to spend just a little bit of time reviewing this type of thing, okay? Being able to find what is 30% of 50 or what percent of 80. Do you guys remember the percent proportion? Okay, somewhere on your paper, I think I want you to write this down. Percent over 100 equals part over whole. Remember that?
Yeah.
Okay, we're going to use that quite a bit. Do you remember what words went with part and whole? Izzy?
Of and is.
Which one went with which? Where does of go? Where does is go? Matthew?
Of his whole is his part.
Yeah, of is whole, is his part. Okay. So write that down so you have that proportion to look at, because when we solve these, we're really just filling that in. Okay. So let's start with this first one. What is 30% of 50? We're just going to set up the proportion. The percent always goes over 100. Do we know the percent?
Yeah.
Yeah, it's 30 over 100. Where should I put the 50? On the top or the bottom? Tyler? Bottom. Because it says of 50. So that means I'm going to put X on the top, and then we're going to solve that. Grab your calculator and solve it. What do you get, Tyler? 15. Okay, remember how to solve that? Do 30 times 50. We multiply the diagonal. Divide by the third number. Okay, so multiply the two numbers on the diagonal. Divide by the third number. So let's try this again. What percent of 80 equals 64? Do we know the percent? No, that's where our X goes. X over 100. Where should the other numbers go? Which one goes on top? Which one goes on the bottom, Brinley?
64 goes on top, 80 goes on the bottom.
64 goes on the top, 80 goes on the bottom, and then you solve it. Multiply our two numbers on the diagonal. Divide by the third number. And what do you get there? Brinley, go ahead. 80%. Don't forget the percent sign. Okay, so that one should be 80%. Okay, the last one here, 25% of blank equals 10. So we know the percent, 25 over 100. Where should the 10 go, on the top or the bottom? Brooklyn? Top. Okay, because we don't know the of. The of is missing. So we multiply the numbers on the diagonal, divide by the third number. And what do you get, Tyler?
40.
40? Yeah. 40 is correct. Okay, questions there? Any questions on that? Okay, then a word problem. I would say most of the problems on the MCA test are going to be some sort of word problem. Okay, so Danielle bought cupcakes for her sister's birthday party. 20% of the cupcakes had sprinkles on top. Of the 20 cupcakes had sprinkles on top. How many cupcakes had sprinkles? So I'm going to set up my proportion. Do we know the percent? Yeah, the percent is 20 over 100. Where should the other 20 go, on the top or the bottom? Yeah, what do you think? Bottom. because that's the total number of cupcakes. That's the whole amount. And so then we're gonna solve this. 20 times 20 is 400 divided by 100. Did you get 4? So 4 cupcakes. I had sprinkles on it. Questions there? Okay, the other thing we talked about with percents is percent increase and decrease, percent change. Do you remember doing that? Okay, and you might need to write this one down also. Percent over 100, change over original. Okay, so we have that proportion, percent over 100 equals change over original. So in the first one it says, what is the percent change from 50,000 to 60,000? Okay, one of the things you guys need to be aware of, if it's multiple choice, you should be able to eliminate some options. Okay, so when I look at these, if I went from 50,000 to 60,000, was that an increase or a decrease? Increase. So that means it cannot be A or B. Agreed? Right, because those say decrease and it did not decrease. So it has to be either C or D. At least, if we can eliminate some choices, we've got a 50-50 chance of getting it right. Okay? Now, we're going to do this. Do we know the percent? No. So we're going to put X over 100. And change over original. What do you think, Izzy?
10,000 over 50,000.
Good. 10,000 over 50,000. Because it changed. It went from 50 to 60, so it changed by 10,000. And it started at, the original amount was 50,000. So then we solve that. And what do you get? Think it. 20. So it's a 20% increase. Okay. Now, most likely, they're going to give you some sort of word problem like this one. Cardell ran 10 miles per hour during Monday's workout and 20% faster during Tuesday's workout. How fast did he run on Tuesday? Okay, so let's set this up. Do we know the percent?
Yeah.
Yeah, it's 20%. So 20 over 100. Do we know the change or the original? We know the original. The original is 10. We're going to solve this. Okay. You solve this, what do you get? 2. Okay, I can almost guarantee you that if you get to the MCA test, here's what they're going to tell you. Here's your options. They're going to say A is 2, B is 8, C is 10, and D is 12. And I'm guessing that a number of you will choose 8. Okay, and here's why you'll choose 8. Because you got 2 right here. Right? And you're like, oh, 2, I see it on the list, I'll just pick that one. It's got to be it. 2 is not the right answer. Why not? Easy.
Because you have to add the 10 miles per hour.
Right. Because we don't want to know how much faster he ran. We want to know how fast he ran on Tuesday. And so he ran faster on Tuesday than he did on Monday. This is the change. So you have to do 10 plus 2, which is 12. So if it was multiple choice, you'd have to choose 12. Okay, so that's why it's so important to read the question carefully. Because for sure, one of them is going to seem like it makes sense. And I know some of you would have gotten stuck on that one and picked A, and then it would have been wrong. So be careful that you read it. Okay, last one here. According to his biking log, Felix biked 4 miles last week in comparison to 2 miles this week. By what percent has the distance decreased? Do we know the percent? No, so x over 100. What was the original amount of miles he biked? What did he start at? Savannah? 4. And how much did it change? He went 4 miles last week, 2 miles this week. How much did it change? Changed by 2. Okay, so we solved that. What percent change is it? Multiply the numbers on the diagonal. 2 times 100 divided by 4. What do you get? 50%. So his distance decreased by 50%. Questions there? All right. Then we go to a reminder of simple interest. Remember when we talked about simple interest? This is the last thing on that front side of the page. Okay. Use the simple interest formula. I equals P times R times T. Remember that? They'll give you that formula on the test. You don't have to memorize it. They'll give it to you, okay? Where I is the interest earned, P is the principal or starting amount, R is the interest rate expressed as a decimal, and T is the time in years. So we need to set this up as I equals P times R times T. And really, we're just filling in the blanks. So Tim has $40 in a savings account that earns 3% simple interest per year. How much interest will he earn in 3 years? Okay, let's start with the first number, this 40. Is that the I, the P, the R, or the T? What do you think? Izzy?
The R.
It's not the R. So, a couple reminders. I stands for interest. Interest is a dollar amount. Okay, P stands for principal. And that's also a dollar amount. R stands for rate, which is a percent. And T stands for time, which is years. So where would the 40 go? Tyler? It's the principal. That's what he's starting with. So 40 goes there. Okay, the next number I come across is 3%. That's the rate, but I can't just put 3 there. How do I have to write it? I can't write it as 3. I have to change it back to a decimal. What's 3% as a decimal? Tyler, what? 0.03. And then the other number I see is 3, which is 3 years, so that's our time. I don't know the I. Okay, so we grab our calculator and we do 40 times 0.03 times 3. What does that mean? 3.6. That's the interest. How much money is that? Savannah?
$3.60.
It's $3.60 in interest. Does that answer the question? It says how much interest will he earn. Does that answer the question? Yeah. What if they said, what's the total amount in the account? Then how would we answer the question? What would we have to add to that 360? He has this much interest, but he also has how much other money? $40. So we'd have to add them together if we want the total amount. Okay, sound good? All right, flip the page. Let's real quickly review just a little bit of probability. We talked about probability last week. Okay, it says write each probability as a fraction, decimal, and percent. It's really not that hard. We're going to write it as a fraction and a percent, because ultimately we just need the percent. So if I was gonna spin this spinner, see, my board knew I was gonna talk about a spinner, and that's why I put a spinner on the board. Okay. If I asked you what is the probability of landing on a 3, what would you say? Probability of landing on a 3. As a fraction first. Let's just start with the fraction. Matthew. 1 out of 6. Okay, now let's turn that into a percent. What percent is that? Use your calculator, just do 1 divided by 6. To the nearest tenth, what percent is that? Go ahead, Tyler.
0.17.
Okay, so your calculator gives you 0.166666. What percent is that though? That's a decimal. What percent? Izzy?
Would be 16.7.
16.7%. Okay, and ultimately we just want the percent. Okay, how about landing on an even number? What's the fraction of landing on an even number? Savannah.
3/6.
3/6. Which one is that as a percent? 50%, right? Half of the time. So 50%. Okay, the probability of landing on a number less than 5. How many of the numbers are less than 5? Brindley? 4 out of the 6. What percent is that? So we do 4 divided by 6. And then move your decimal back to, Tyler, go ahead. 66.7%. And the last one, landing on a 5 or a 6. Landing on a 5 or a 6. Friendly. 2 out of 6. 2 divided by 6 is 33.3%. Okay, that's not so bad. Those are the kind of things we did last week. Now, I need you to look at this word problem. So Jason spins the spinner 40 times. It lands on 3 or 4 10 times. How many times does Jason need to spin the spinner and have it land on a 3 or 4 to have the relative frequency equal the theoretical probability? Is that confusing? Okay, I think there's some words that we've never seen in there. And I don't know why they use this right here, relative frequency. Whoa. Okay, I'm not sure why they use relative frequency. You guys, all that means is experimental probability. Okay, so theoretically, what's the theoretical probability of landing on a 3 or 4? Two out of 6, right? Or 33.3%. Everybody agree with that? So far, his relative frequency is 10 out of 40. If I use my calculator and I do 10 divided by 40, I get 25%. Are those equal? No. Okay, so the question is, how many more times would he have to spin the spinner and have it land on 3 or 4 to have them be equal? So let's see if he just spun it one more time. Then he would have spun a 3 or 4, 11 out of how many? 41. Everybody agree with that? Okay, 11 divided by 41 is 26.8%. Are they equal yet? No, so he has to spin more than one. Okay, so he spins it again. Now what's his relative frequency? If he spun it one more time, it'd be 12 out of 42. 12 divided by 42 is 28.6. Getting closer. Still not enough, so we have to spin again. Now what would it be? Izzy,
Well, never mind.
do you have it?
Yeah.
What do you think it is?
15 out of 45.
Okay, so he'd have to keep going. 13 out of 43 would not be enough. 14 out of 44 would not be enough. 15 out of 45. If you do 15 divided by 45, that's 33.3%. So at this point, it's equal. How many more spins did he need?
5.
5. Okay, so you would need 5 more spins to have them be equal. Okay, that's kind of a confusing problem, I think. It's a little bit tricky. I want you to be aware of it. You have that type of problem to look at. Okay, last thing. The theoretical probability that you randomly choose a green marble from a bag is 3/8. There are 40 marbles in a bag. How many are green? Okay, you guys, the easiest way to do this. If the probability is 3/8, 3 out of 8 are green. Let's set up a proportion. How many out of 40 would be green? We can solve the proportion. If 3 out of 8 are green, how many out of 40? What do you get? Go ahead. 15. So 15 marbles are green. Okay? Questions there? All right.